So we've always talked about AI and ML as, or jobs in this area, as things that happened, in academia and in research. That's always been the case, all through the 90s, all through the 2000s. A lot of these problems are not new, right? We've been trying to solve handwriting recognition, object character, OCR. We've been trying to solve some of the natural language processing problems, in the early 2000s, in the 1990s, and in some cases, all the way back to industrial applications in the late 80s. So this is not new. What's new is obviously the ubiquity of computing, the packages, the ease of use of a lot of the supporting tools. And like I said, a couple of decades ago, you would have got a PhD for building a neural network, whereas now it's a function call, right? And that ease of use and that access to the sophisticated tools has actually made it much more prevalent and much more pervasive, and us now thinking about the applications and what all we can do with AI and machine learning. Okay, so how does this map to jobs and careers and so on, right? Obviously, as I said, a vast majority of the jobs in this area will hinge around the machine learning, that part of the circle. Right? A majority of applications that tend to get built tend to, take in to some extent an assumption of clean data, or data that has already been manipulated, that has already been, painstakingly cleaned and parsed out, so that the machine learning model works smoothly. And the assumption is that we, the humans, will be the interpretive layer that take this decision and figure out what to do with it. Right? We don't yet have very many widespread, large-scale examples of truly sophisticated speech synthesis or natural language generation. Speech synthesis maybe, but not natural language generation. So, a vast majority of the areas tend to be around the machine learning area. So, what kind of jobs are we talking about? We're talking about data scientists. We're talking about data analysts. We're talking about machine learning engineers. We're talking about what would typically be called part of your data science team, right? So these are people who are trying to be more analytical. Yes, there are going to be some jobs in the speech synthesis, natural language generation, especially on robotic process automation and some of the output elements, right, where a lot of the the jobs tend to focus around again, academia, research, and sometimes on the cusp of those two, but they're not widespread yet. But again, with the ubiquity of sensors, with the ease of use of sensing and processing data, whether it's coming from vision, speech, or other input sources, some of the left-hand side of the circle is, jobs in those areas are starting to become more prevalent. So you might have computer vision jobs, you might have speech recognition jobs. As we're trying to use more and more OCR and biometrics and even recognition that companies like Facebook use to take some of the burdensome tasks away from us, those kind of jobs start to become a lot more relevant, right? Some of you may know that Facebook's tagging algorithm for picking out who the person is in a particular image has actually started to get more accuracy or greater accuracy than even a human counterpart. Right? What does that mean? That means that these Facebook algorithms are doing a much better job at recognition than humans do sometimes. So that's designing a system that does that, designing a system that can accurately and sufficient and do that at sufficient scale is something that's starting to become very valuable, but again, largely in product companies. Now, having said all of that, there is a class of problems here that we haven't really talked about. And that specifically is big data. Now, it seems orthogonal to everything we've talked about here. We've talked about AI, machine learning, and all of that. But quite commonly, you'll also hear the phrase big data thrown in. How does that work with this whole class of problems? Well, really, the problem of big data and the associated kind of techniques and tools have existed for a really long time. They're not new either. Again, what's changed is the sophistication of the tools that have been developed. A host of open source technologies developed by Apache and the likes of them, with Spark and all these people, and also just really, really good cloud computing. And what all of this has enabled us to do is to build, is to acquire, process, and actually manipulate data at much higher rates with much higher accuracy than we ever could. That's all it is. Now, in a very, very grand scheme, the way you can think about it is that big data is kind of like this giant database that acts as the input to everything else that we're trying to do, whether it's machine learning, whether it's NLP, whether it's speech synthesis, whatever else it is. And the more rich and robust and big and sophisticated our database or data set, the more we're able to do in terms of accuracy of our algorithms, accuracy of the kind of generative aspects that we're trying to build, or accuracy of the predictive systems that we're building. So that's how big data relates to all of this. So in terms of the core of what we're trying to do analytically, algorithmically, small data, big data, they're all the same. If you have sufficiently good data, you don't necessarily need some of the big data tools. But for all of the data and information that we're talking about that keeps coming in and out at very rapid rates, if we don't have good ways of being able to handle it and use it effectively, all of these algorithms and everything and systems that we're trying to build are meaningless. So while they go hand in hand, they're not necessarily the same field, and they're not necessarily the same set of skills. So I hope that explains what AI and machine learning is, where the jobs are, how should we be thinking about the whole space, and how should we be interpreting some of the elements within this area.